and welcome back to part 2 of surface tension experiments. So on this one you are going to need to make your own boat. So you can make this out of a milk carton or an old cardboard juice carton, or I made mine out of a paper plate. So you can something that's nice and thick, so even cardboard would work too. So I've cut out a little shape for my boat and give it a nice point at the front, and then I have cut out this shape here, which is its engine. So it's really important we have that opening for the engine. So if you watch what happens, and then I will explain the science behind it. So I'm going to drop my boat into the water, okay, and then I'm going to get some fairy liquid. I'm going to very carefully, whoa, amazing, did you see that? So I dropped in some fairy liquid into the engine at the back and it powered our boat forward. Nothing else was used. So it's really important that you get the soap into the back where the engine is. You could make that into a competition. You could have two sides of the baking dish and you could see whose goes further. You could even go even further by adding in different materials or liquids like we did before. So somebody could have milk, somebody could have the fairy liquid, and see what happens. To insert the soap, you could use a cotton bud, you could use a straw, you could use a toothpick. Now, what is happening? There's lots of different things happening inside this experiment. Now, the soap is added into the back of the boat, and what that is doing is that is causing the soap to come out of the back of the boat. Now in front of the boat is where the water is, so the soap comes out of the back, and that causes the boat to push forward. So it is the principle of, for every action there is a reaction. So the soap comes out the back and that causes the boat then to power forward in the water. Why does it power forward in the water? Because the water molecules in the water are stronger than the water molecules in the soap. So it has a greater surface tension, and because it has a greater surface tension, it pushes the boat forward. It also has the Marangoni effect, which is where it goes from the low to the high water tension. So it goes from the low soap tension to the high water tension, and because the water is stronger than the soap, the fluid flows from the back of the boat and pushes the boat forward. So I really hope you enjoyed that one. Lots of science involved there, but you can also have lots of fun and have a competition too. Let me know what you're up to, and I can't wait to see your experiments in action. Why isn't the boat propelling forward now? Because in here, all we have is pure water. So the boat is floating on the surface. It's nice and still because the surface tension in the water is the same. So the water is nice and sticky, so it allows the material of our boat to stay on the water. Why does the boat move forward? Because we add in the soap molecules. And that is the difference between the soap molecules and the water causes that boat to push forward. So, visually, you have your boat here and you put in your soap at the back. This then creates a low surface tension because our water likes to stick together. When we put in our soap, it weakens it, so the surface tension isn't as strong, so the liquid isn't as strong. So this is an action because it's created a low surface tension. Then at the front of the boat, you have got your water here away from the soap. So this here is still really high because the soap hasn't got there yet. So because the soap comes out the back, creates that low surface tension, that is the action. But then in science, that creates a reaction. Because the water molecules are much stronger, so they have a bigger surface tension, so they pull the boat forward. There's also another scientific principle in here, and we call that the Marangoni effect. So the fluid likes to go from a low surface tension to a high surface tension because the water is stronger than the soap. And that is called the Marangoni effect. So I hope you enjoyed that. That is a little bit on surface tension. If you want to take that into real life, it is the same as when a bird flaps its wings, so it presses down onto the air, and because it's pushing down on the air, that causes the bird to lift. So that is very exciting when you think about the principle being used in our science experiment to birds who are flying around each day. So I hope you enjoyed that, and let me know what you have been up to. Thank you.